Okay, so welcome back to the video on Simpson's one-third rule. And in this video, I'm going to solve an example using Simpson's one-third rule. Okay, so this is the same example back from the video of trapezoidal's rule. A solid of rotation is formed by rotating about the x-axis. So we can form a solid by rotating an area around x-axis. So solid of rotation is formed by rotating about the x-axis. So what we are going to rotate about x-axis? The area between the x-axis, the lines x0 and x equals to 1. So let me draw those lines. So if this is x and this is y, so a line x equals to 0 means that line or y-axis, so this is line x equals to 0 and x equals to 1, so maybe somewhere here we have x equals to 1, and the curve through the points with the following coordinates. Okay, so there is some curve that goes through those points. So let me use orange color to draw the curve. So maybe this curve has a shape like that. Okay, so we are interested in the curve or the portion of the curve between x equals to 0 and x equal to 1. However, this curve may extend beyond those two lines, x equal to 0 and x equals to 1, but we are not interested in those portions of the curve which are outside those two vertical lines. So what we're going to do here is there is an area which is formed by x-axis, so this line x equals to 0, this line x equal to 1, this line, and then on the top that area is constrained by the curve that goes through those points. Okay, so in reality this curve will be very different. I have just drawn it approximately just to give you a picture of what is happening here. So this area is restricted by x-axis from below, by x equal to 0 line from left, by x equal to 1 line from right, and this curve from top. Okay, so let me hatch the area. So that area is that area which is restricted or constrained by those four lines, and there is a solid obtained by rotating that area. So let's say that this is the axis of rotation, or x-axis itself is the axis of rotation. So what we do is we take this area and then we sweep it or we rotate it around x-axis to get a solid. Okay, so in 3D that solid may look like this. So after rotating, maybe we'll have a solid of that shape approximately. So we get a and mind this is the axis of rotation, so that is x-axis. So this is a solid which is obtained by rotating that area around x-axis, and we want to find out the volume of this solid using Simpson's one-third rule. And for that the formula of integration is given. So estimate the volume of the solid form, and the volume of this solid is analytically given by this integration formula. Okay, now we will use Simpson's one-third rule to find the volume of this solid of rotation. Okay, Let's do that. This is the same formula from the previous slide. Again, it's the same data, and this data represents the pairs of x and y through which that curve forms. So maybe graphically this will look like, if again this is x and this is y, then first is x equals to 0, y is 1, 0.25, y is slightly less, 0.5, 5 slightly more, 0.75 and 1. So maybe that curve actually goes through those points like that. So you may plot this on GeoGebra if you want. Okay, and that's how we then we use those additional lines and x-axis and rotate. Okay, so anyway, so we want to modify this formula for our use, and that's why, as you can see, that instead of y we have y squared. So in this formula we need to make a modification so that from this formula we arrive at this formula. Okay, so how we get this formula from the known formula of Simpson's 1/3 rule. Okay, so first of all, a is the lower limit, so a is 0. Again, you can see here that first data point is known at x equals to 0. Then upper limit of integration b is 1, and this matches with the last data point given in the data set. And then this integration is multiplied by pi. So let us multiply by pi. So I should multiply it here by pi. So this thing will be multiplied by pi. Okay, and then you can observe that we don't have y, we have y squared. So this is the only change which is left to make. So let me change this to y squared. Okay, so that means now I will have to substitute values of y squared. So you know that the first row in that table represents values of x, and the second row in the table represents values of y. So for example, this is y0, this is y1, y2, y3 and y4. So as this is y is equals to f of x, and we don't need y's, we need the square of those values. So this table at the bottom, so this shows the same data, but only the difference is that values of y are squared in the second row of this table. Okay, so if you look at the first value of y, the square, this is squared and this is y0 squared. Similarly, this is y1 squared and so on. So this is y4 squared. One more thing I would like to mention here is that, as I mentioned in the previous lecture or last video, we should ensure that the number of data points given is odd, okay, so that the value of n is even. Okay, so if you count the number of data points given in this problem, we have 1, 2, 3, 4 and 5, and hence n becomes 4 here. Okay, so we can apply Simpson's rule to this problem. Okay, so let us do that. Let us first reduce the formula of Simpson's 1/3 rule to n. So what is n here? Okay, so first we need h and we need n to solve the problem using the given data. we want to find out h. As mentioned in the previous video, h is nothing but the step size. So I can use any two consecutive points in the given data to find out h. Okay, I can either use these 2 points, or I can use these 2 points, or any two consecutive set of points can be used. Okay, so 0.25 minus 0 is 0.25, or 0.75 minus 0.5 is also 0.25. Okay, so h is 0.25. Then n is number of given data points minus 1. Hence we have 1, 2, 3, 4, 5. 5 minus 1 is 4, and hence the value of n is 4. Now using value of n equals to 4, let us reduce this formula of Simpson's one-third rule. Okay, so now the limits of integration are put as 0 to 1, and instead of y we have y squared. So the value of h is 0.25. So value of h is 0.25. Then starting with the first green colored term in the square bracket, we have y0. So of course this will be squared this times, and then the blue colored bracket, first blue colored bracket, yn minus 1. So as n is 4, this is 4 minus 1, 3. So the last term in the first blue colored bracket should be y3. Hence there will be only two terms in this bracket, y1 and y3. Then the second blue colored bracket, last term should be n minus 2, as n is 4. 4 minus 2 is 2. So y2 should be the last term. So there will be only one term in the second bracket. And finally the brown colored term in the square bracket, last term in the square bracket. So this becomes y4 as n is 4. Okay, so this is the formula of the Simpson's one-third rule for this problem, where n is 4. Okay, so let us actually substitute the values and find out the answer of the integration. So let me erase the data. So we don't want this. Okay. So y0 is 1. Then y2 plus y1 plus y3. Last term is y3. So y1. So let me write the values. This is y0, y1, y2, y3, and y4. So this bracket, the first blue colored bracket, has two terms, y1 plus y3. So y1 is 0.9793 plus y3 is 0.81 plus 2 into y2, only one term in the second blue colored bracket. So this should be 0.9195 plus the last term in brown color is y4, hence 0.7081. Okay, so if you calculate this value, you should get it as 0.8197. Okay, so you can verify that value using calculator. Then we want the value of v. So v is equals to pi times that integration in second step. So pi into that. So we pi multiplied by this value. So this value goes into this bracket. So pi times that value gives us final answer, which is 2.81. 2.8197 2. So that is the final answer, and you can compare this answer with the answer that we obtained using trapezoidal rule. There is a slight difference, and accuracy is more with Simpson's 1/3 rule. Okay, so I hope that you have understood how the calculations work in Simpson's 1/3 rule, and the formula is pretty straightforward. You need to substitute the values. Okay, fine. See you in the next video.